Hello, welcome to GP Podcast. Today, we're diving into something that happened in early 2026, a series of technological breakthroughs out of China that seemed to appear almost out of nowhere, completely rewriting what we thought was possible in computing, AI, and even energy.
Seriously, think about this. In just the first couple of weeks of 2026, a string of announcements came out that just sent shockwaves through the global scientific community. And we're not talking about press releases or some distant corporate roadmap. No, these were real, verified results that just shattered limits many experts believed were still years, maybe even decades away.
All right, so here's how we're going to break all this down. First, we'll talk about just how sudden this whole tech surge was. Then, we're going to get into the three huge breakthroughs: a brand new way to do computing that finally gets us past the limits of silicon, a hyper-specialized engine for AI, and a massive step forward in creating artificial suns. And finally, we'll try to connect the dots and figure out what it all means.
I mean, just imagine, within a few days of each other, researchers announced they could build transistors without silicon down at the 1 nanometer scale. Then they showed off AI hardware 4 times faster at its one specific job, and then they managed to contain fusion plasma in a way that was, frankly, thought to be impossible. So let's start at the very foundation of everything, the humble transistor.
You know, for more than half a century, our entire digital world has been built on one thing: silicon. Every phone in your pocket, every server, every AI model we have, it all exists because we got really good at shrinking silicon transistors. But that incredible run is now hitting a wall, a hard wall, and the reason is simple: physics.
As you shrink these things down to the size of just a handful of atoms, silicon kind of loses its grip. It can't control the flow of electricity anymore. The current just starts leaking out all over the place. Power efficiency tanks, and the whole device just stops working reliably. For years, scientists have been saying, hey, silicon is running out of road.
And yeah, that is the multi-trillion-dollar question, isn't it? For a long time, the answer, at least in theory, was to use these new exotic two-dimensional materials. I'm talking about stuff that's literally only a single atom thick. But every time someone tried to build something with them, it was a total failure. And here's the twist: the material itself wasn't even the problem.
You see, the real bottleneck wasn't the fancy 2D material. It was how you connect a wire to it. Every single time researchers tried to just place a metal contact on top, it created this messy, high-resistance connection that was basically useless. The real game-changing idea from Nanjing University was to stop placing the contacts and start growing them, atom by atom, directly onto the material itself.
They used this incredible technique called molecular beam epitaxy, which is kind of like an atomic-scale 3D printer. It lets them deposit single atoms of antimony one by one onto a layer of molybdenum disulfide. And then the atoms just self-assemble into a perfect crystal, forming a flawless bond. It's just an unbelievably elegant solution to a problem that had the world's best scientists totally stumped for over a decade.
So here's the kicker: this isn't a theory anymore. They actually built it. They have a working device with contacts that stay super efficient even when shrunk down to the tiny sizes needed for the industry's future 1 nanometer technology. This is the first real concrete proof that moving beyond silicon is actually possible.
Now, this pattern of rethinking the absolute fundamentals doesn't stop with the transistor. Right around the same time this was all happening, another team was taking a completely fresh look at the hardware that powers artificial intelligence.
You know, today's top AI chips, like GPUs, they're amazing because they're so flexible. They can do almost anything you throw at them. But that flexibility, it comes at a cost, both in energy and efficiency. So researchers from Peking University went the other way. They built a specialized architecture designed to be the absolute best in the world at just one, but supercritical mathematical operation, the Fourier Transforms.
And the result of specializing like that is just mind-blowing. By tailoring the hardware for this one specific task, which is vital for things like signal processing and new kinds of AI, they went from about 130 billion operations per second to almost 500 billion. That's nearly a 4 times increase in speed, and it uses less power. That is a monumental gain in efficiency.
Okay, so from the microscopic world of transistors and AI, we are now going to zoom way out to the cosmic scale of trying to build a star right here on Earth. This final breakthrough happened in the wild world of nuclear fusion.
So fusion reactors, right? They work by heating up hydrogen gas, or plasma, to temperatures hotter than the core of the sun. We're talking over 100 million degrees Celsius. The massive challenge, as you can imagine, has always been how to contain that superheated plasma using these incredibly powerful magnetic fields.
For decades, all of fusion research has been stuck inside this invisible cage. It's called the Greenwald limit. It's basically a law that says there's a maximum density for the plasma. If you try to pack the atoms any tighter to get more fusion going, the plasma just becomes unstable and the whole reaction collapses on itself.
But now, researchers at China's East Reactor have broken out of that cage. They managed to sustain plasma that was 1.65 times denser than the Greenwald limit, and it didn't collapse. This is the first time anyone has ever done this under conditions that are actually relevant for a future power plant. They've literally stepped into a new realm of physics that, until now, only existed on paper.
So, let's step back for a second. What happens when we stop looking at these three things as separate events and instead see them as a pattern?
So let's just quickly put it all together. In computing, we suddenly have a real viable path beyond silicon. In AI, a huge leap in efficiency by specializing the hardware. And in energy, a fundamental barrier in nuclear fusion that has stood for decades has just been shattered.
Now, look, these aren't just small, incremental improvements. Each one of these represents a fundamental wall being broken down. And when you see them all happen at the same time, from the same place, well, it forces you to ask a really big question about the future of technology on this planet.
Has China started winning the race for the technologies that are going to define our world for the next century? That's the big, provocative thought we'll leave you with today. If you liked the video, subscribe, leave a like, comment on what you liked most, and share the video.